Now that I warmed up, let's take a look at the fourth layer. This layer is above the mesosphere, which means it starts at about 80 kilometers and goes as high as 480 kilometers. Whew, that's really high. Now this layer will contain nitrogen and oxygen. So you have all these molecules of nitrogen and oxygen hanging out up there. But something weird's actually going on. These molecules are actually fairly far apart from each other. Now, the oxygen is really good at absorbing this intense solar radiation. So if we learn that the ozone layer gets pretty warm because of how much solar radiation it absorbs, and we know that the oxygen in the thermosphere can absorb a lot of solar radiation, what do we think the temperature is going to be? Let's find out. Hot! I guess I didn't need to walk off to warm up. We just needed to go to the next layer. The thermosphere reaches temperatures of 980 degrees Celsius. Okay, maybe I did need to go warm up somewhere else. I burn up in that temperature. Now, the thermosphere also contains the exosphere. Now, if you remember when we were looking at the different layers earlier, we saw that the exosphere was the outermost part. Well, it is the outermost part, but it's the outermost portion of the thermosphere, which happens at the very end, which is at 480 kilometers. Now, something really interesting can happen here. Gases can actually escape Earth's gravity at the exosphere. I guess it's far enough away that gravitational hold on the molecules is really weak. So it's still in Earth's gravity, but it can fly off, which also means that molecules floating around in space can also get caught in. That's pretty cool. Let's see if there's anything else we can learn about the atmosphere.
Oil, like the same murderer.
That's leaping to a conclusion.
I said looks like that. Looks like it's not leaping.
Her phalanges, fingers are damaged. Metacarpals are cracked.
You've seen something like this before?
In Iraq, there was some remains. They've been buried alive.
This person was buried alive?
I'm not comfortable.
It looks like this person was buried alive, correct? The tattoo?
Looks like we have another layer. Well, it's not really a layer per se. You actually have solar energy absorbed in this layer. Now this layer is actually part of the upper mesosphere, which is our third layer, and the lower thermosphere, which is our fourth layer. And what happens is this solar energy will electrically charge ions. These will allow radio waves to reflect. So the image that we're seeing here is radio waves hitting the ionosphere and then bouncing off. But that doesn't mean they can't still make it through. I mean, as we know, there are tons and tons of satellites up in space. So the radio waves can also travel through the ionosphere, but as you can see, it will alter the course. And it will then get caught up by satellites in space. So this means that if you were to send me something via satellite from California, and I, here in New Jersey, would be able to get the information due to this interesting effect. Now, since it has to do with solar energy, you'd figure something's going to happen at night when we don't have the sun. Well, you know what? You're right. Because the sun's not on this part of the ionosphere at night, the ionosphere will actually move a little higher. That's because the electrons down here get affected by all the radio waves. So they essentially get used up. And because the sun isn't out to electrically charge these ions, the bottom layer will start to dissipate, moving the ionosphere itself up higher. Now something really cool happens whenever that occurs. The radio waves, since they have to go higher, means that they hit at a different point in the sky. That also means that they will reflect back down even further. So I could be in the middle of the Atlantic Ocean, and you in California would still be able to talk to me. That's pretty cool. Let's see if anything else happens in the ionosphere. Well, I'll be. There is something else. Wow, that's awesome. This is known as an aurora. An aurora is a colorful light display that occurs in the ionosphere. Energetic ions from the sun hit atoms and molecules that are in our ionosphere. This causes them to emit photons or light particles. We usually get to see these at the magnetic poles, your north and south poles. As we can see, we have the aurora borealis, 2 images of it. Guess it looks different each time. Kind of makes sense, doesn't it? Considering the sun's going to hit it differently each time. And then you have the aurora australis. This is found down in Antarctica. This is pretty neat. Well, maybe one day we'll get to go up to Alaska and take a look at this stuff for ourselves. But in the meantime, we just finished talking about all the different layers of the atmosphere. Let's review what we've discussed. First, let's go over our key words. At this point after this review, you should be able to define and understand what all these words are. So why don't you try and test yourself? What's the atmosphere? The troposphere, the stratosphere, the ozone layer, the mesosphere, the thermosphere, the auroras, altitude, solar radiation, exosphere, and ionosphere. Now let's review everything we've discussed up to this point. The atmosphere contains 4 layers. First is your troposphere. This is where we live and all the activity around us happens. The second is the stratosphere. This is where the ozone layer stays. The third is the mesosphere, which is the coldest layer if you remember. Fourth is the thermosphere. This is the outermost layer, which also includes the exosphere. The ionosphere is the top part of the mesosphere and the bottom part of the thermosphere. The ionosphere has the ability to reflect radio waves, and it also can create auroras. Well, I hope this helps you. I know it definitely helped me. I look forward to seeing you again when we start discussing the carbon dioxide-oxygen cycle. Until then, good luck.